Okay, I'm going to talk about binomial distribution and the application of it. So most of our examples deal with airlines and hotels. So this example number one is a flight. It says it holds 220 passengers. The airline finds that the probability of a passenger not showing up is 5%. So when that happens, the flights, they always overbook. They sell more than 220 tickets just to make sure that their flight is full and they can get the most money possible. So what they do is they decide to sell 225 tickets. Would this be a good idea? Okay, so step one, we're going to find the mean, and that is the value of n times p. Okay, so our n is 225 tickets. The probability that people show up is 95%. Okay, so our mean is 213.75. Okay, then we have our standard deviation. So does it make sense with the mean? That's about how many people should be showing up. Standard deviation formula is the square root of npq. Okay, so let's figure out what that is. And we have the square root of 225 times 0.95 times 0.05. So P show ups, Q would be the not show up percents. Okay, so that comes out to 3.27. Okay, now what do we do with this information? Is this a good decision or not? So what would happen for it to not be a good decision would be the percent of overbooking would be really high. That would make for a bad decision, right? So let's find the probability that more than 220, right? Because then you're overbooked and that's not a good decision. So let's see if this is high or not. Okay, so we need to do a z-score lookup. Okay, for more than 220, I'm going to use, some do the 220.5. Some people you'll find just do the 220. So we'll do 220.5 for more than 220. Subtract the mean divided by the standard deviation. Okay, so we get a z-score of 2.06. Okay, so thinking about this, we want to know what the percent is. Okay, so we're going to look up on our chart. Okay, and when we do that, we get 0.4812, and we know on that side is that, or you could do 0.5 minus 0.4812, and you get 0.0188. Okay, so in this scenario, you would have a 1.88% chance of basically too many people. So would you say that airline is pretty safe to sell 225 tickets? I would say that that would be a pretty safe probability. You do not have much, there's not much chance, not much probability to overbooking. Does that make sense? Okay, so let's do another plane example. Okay, let's see what the scenario could be. There's 211 seats on the plane. Okay, probability of not showing up. They have a statistic that says that's your probability that you not show up. Okay, so let's go. We're going to find the mean. Actually, first of all, I better tell you that this company decides to sell 234 tickets. Okay? Okay, so the mean tickets that would sell, or theoretically, would be 234 times P, the probability of showing up, which would be I'm sorry, this should not be that high. That was like a 67%. I wanted 6%. Okay, so probability of not showing up is that, so probability of showing up is 93%. So 0.9328. That makes a little more sense. Okay, so our mean is 218.275. So that's the mean number of people that would come. And our standard deviation then would be 234 times 0.9328 times 0.0672 and square root. Okay, so our standard deviation comes out 3.83. Okay, find the probability of not enough seats. Okay, so what is that? We're going to be working with our x value of 211.5 then. Okay, so z-score that relates to that. So 211.5, subtract the mean, divided by the standard deviation, comes out to a z-score of negative 1.769. And then, if there wasn't enough seats, that would be the situation above that. Okay, so chart lookup. And we get 0.4616. So that goes there. And then this is a 0.5. So the probability not enough. Oh man, not enough. Not enough seats is 0.9616. Whew, that's some pretty bad statistics there. So this is not a good business decision. Right? That is a bad decision there, because that's a high probability that you're not going to have enough seats. Okay? Okay, let's check out a hotel one then. So a hotel has 300 rooms in it. Okay, the probability that you have a no-show is 0.15. Okay, here's the question. Find the probability of more than 290 guests. Okay. So here's what we're going to do. Our mean is 300 rooms times the probability of people coming. So our mean is 255 rooms get filled for an evening. And the standard deviation, square root of NPQ, 300 times 0.85 times 0.15. that's 6.18. Okay, so we're going to be testing with this as our x value. Since we're going to do more than, we're going to use 290.5. So what is the z-score that relates to that? So 290.5 to represent more than 290 minus your mean divided by your standard deviation. So your z-score is negative 1.54. And you want the probability of more than. Okay, so chart lookup. And we find the chart gives us a 0.4382. So the final probability would also have to include that 0.5. So 0.9382. So you have a 93.82% chance of filling more than 290 rooms. That's what that is meaning.